Hello, my name is Simon Quasi.
And I'm Kiana Cummings.
Hi, I'm Giselle Mello.
Hello, I'm Jalen McCook.
And I'm Jalen James, and we're doing forces.
Here are the types of forces. A contact force is a force in which one object is in contact with another object. Another force is called a normal force, in which this force is perpendicular to the surface along with the object it touches. A tension force is a contact force on a string or rope, whether it's upwards or downwards. And finally, a friction force is a force that acts in the opposite direction of the motion the object is pulled or pushed towards. Gravity is the force of the earth that pulls objects towards its center, and the units of that is 9.81 meters per second squared. Mass is the amount of matter in the object, and weight is the force of gravity due to the mass of the object, and it's measured in newtons. Weight is also the force which equals the mass times acceleration. Gravitational mass is the amount of matter pulled down by the gravitational force. Fg equals m times d.
Isaac Newton created 3 laws in the 17th century. The first law is whenever an object at rest will remain at rest unless acted on by any forces. An example that I will give for that is grabbing a chair, you push, and it goes into motion. But like his first law states, whenever it has no force, then it stays at rest. That's his first law. Okay. The second law is a force will create an acceleration within the same direction if a net force acts with it on its mass. So that's sort of what I did the first time. So when you push a chair, that would be an example of Newton's second law. Okay. And Newton's third law is an object moving in one direction will have an equal magnitude of another object in the opposite direction. So if I could please have someone help me. Once again with the chair. If I push in the same direction, she pushes in the same direction, the object will remain there because equal forces are being exerted on opposite direction.
So the net force is the summation of all the forces acting on one object. So if I have a chair and I put a force this way, then it'll move. If there's a force acting on it in the opposite direction, it'll move. And the summation of all the forces acting on an object is the net force. Also, I'm going to be talking about ropes and pulleys. The direction of the force is exactly along the direction of the rope, with its magnitude being the tension of the rope. A rope only has a certain maximum force, so there's tension in each of these ropes, and the direction of the force changes as the magnitude remains the same if a rope is guided over a pulley. To lift heavy objects, ropes and pulleys can be used together to accomplish that task with negligible mass on 2 pulleys. The force applied to suspend a mass object is half as large as the force used to pull up on a rope without any pulleys, making it a force multiplier. So the more pulleys you have, the less force it takes to move a mass, a certain mass.
Okay, so applying Newton's law in general. Well, for like every example of an object, there's like an equal and opposite force. So like, for instance, with an inclined plane, you have an object, you have friction, and the friction is the opposite of the direction that it's trying to go. You have the normal force, which is the opposite of the weight. So another example is like when you sum the forces in the y direction, you have to take into account the normal force and then plus the weight of the object and the angle that it's inclined at. And then that will equal the mass and acceleration.
The magnitude of the static friction force has a maximum value that is proportional to the normal force. So the force needed to start moving an object is more than the force that is needed to keep moving the object. So if I put a strong force on this object, I get it going and then I no longer have to force it and it continues to go. The drag force is the magnitude of the friction force that is described as F drag is kinetic energy velocity squared. And the terminal speed is when the upward force of air resistance and the downward gravitational force equals each other